Good morning, guys. Welcome to science class. How does energy affect motion? We continue working with this topic. Copy, please, what potential energy is. Energy, okay, first of all, is the ability to do work. The ability to do
Copy that,
work.
Miss.
Yes, copy. The ability to do work. Copy the two, yes, please copy this. The ability to do work. That's energy. Yesterday, we saw that force. Force is a push or pull, okay? Force. I apply force when I open the door. I apply force when I close the door. I apply force when I open my notebook. See? I apply force. Or when I close it. When I write down, because to write down, you need to press, you need to push the pen or the pencil against the page. If you don't push, you're not going to write anything because the pencil is not going to work. You need to apply force. So the energy is the ability to do work. The ability to do work. If I apply force to open the notebook, but I don't open the notebook because the energy, the force that I applied was not enough. Camera, Alan. Because if the amount of force that I applied was not enough, so I couldn't open the notebook, I didn't do work. I didn't do work. Potential energy, energy that an object has because of position. Because of position, okay? How to measure potential energy? The standard unit for measuring potential energy is the joule. Joule, which is abbreviated as J. Joule. Yeah, okay. Sorry, you know that everything is measured using different units of measurement. Alan, what's the problem you have that you cannot turn on the camera?
It's my internet, Miss.
Okay. So, if you're gonna measure weight, you measure it in pounds, in kilograms. Okay, if you measure weight, you measure it in pounds or kilograms or grams. If you measure volume, you measure it in liters. You can also measure it in gallons.
I finished the copy, Santiago.
You can measure it in milliliters.
Maybe we need to copy the part that says how to measure pottery.
No, just energy. Copy, only copy these two definitions.
Okay.
But if you can copy everything, go ahead. You can measure solid, okay? The amount of matter on an object. How do we measure the amount of matter of an object? We can measure in cubic unit. Cubic unit. Cubic meter. Cubic meter. Like that. So if we're gonna measure energy, how do we measure energy? We have to measure it in joules. In joules. Esa es la unidad de medida. Joules. If I have to measure the wind, we need a special tool and a special instrument. Oh, another thing, to measure volume, we need a graduated cylinder, okay? A graduated cylinder that indicates us the amount of liquid inside the container. If we want to measure, for example, the amount of rain that falls during a storm, we need a special tool. But we can also measure it using a simple glass. We put the glass on the outside, and after the rain, the storm finished, we measure the amount of water using a ruler. So we know how many inches of water falls during the storm. Okay.
I finished Miss Hazel.
Okay, Hazel. Who is copying, guys?
Tua.
Tua. Let's wait for her. Copy, please. Kinetic energy. Kinetic energy, it is the energy of motion. Remember the video?
Miss Alance. Energy.
Kinetic energy.
To copy.
Yes, you need to.
Potential.
You need to. Yeah, copy.
We only copy kinetic energy.
No, copy everything. Copy kinetic. Let me change this color. Kinetic energy is the energy of motion. Potential energy is a stored.
To copy?
Yes, copy the
Only
underlying
the
information.
line,
It is. Listen, copy the underlying information, as I said. Potential energy is a stored energy, while kinetic energy is the energy of motion. When potential energy is used, or let's change this. Let's copy this better because you already have that. You have what potential energy. Copy here. When potential energy is used, it is converted into kinetic energy. Copy that. Kinetic energy is the energy of motion. When potential energy is used, it is converted into kinetic energy. You can think of potential energy as kinetic energy waiting to happen. Okay. Now the illustrations we have here, the green ball has potential energy due to its height, por la altura. Okay. And the purple ball has kinetic energy due to its velocity. Continue, guys. This one is the last exercise we have. Here. Here. Attention, please. You don't need to copy. Potential versus kinetic energy. Take a look at the chart to see some examples of potential and kinetic energy. Potential energy. These one are some examples. A cart sitting in the driveway. A ball in a basketball player's hand. Okay, the ball in the hands of a player has potential energy. A sleeping child. You, while you're sleeping, you are sleeping. Okay, you are resting. You are still, but you have potential energy. A log in a fireplace. A lamp. Kinetic energy. A car driving down the street. A ball bouncing down the court. A child. The court, it is one court. Have you seen that in basketball there is a piece of wood? Y aquí, here is the ring. Aquí está el aro. Right? Something like this. So this one, this piece of wood is court. A esto se le llama the court. So that's what it says, the ball bouncing down the court. Esto es el court y esta es la net. Esto is a court. So you throw the ball and bounce on the court. Sometimes you make a basket. Sometimes you make the basket, sometimes you miss it. You miss the basket. Okay, a child.
So that if you miss that, you throw the ball and it doesn't enter.
No.
For example, the ball falls to another side, that's missing.
Exactly.
But to do it is to throw it in that net.
A child jumping on the bed, a burning log, a lamp turned on. If it is turned on, has kinetic energy. Okay, so look at the picture below and label them potential or kinetic based on what type of energy they are showing. What is this? Potential or kinetic?
Kinetic.
Kinetic energy, you think?
No, potential.
It's potential energy because it has energy, store energy. If you put the batteries on a car, on a toy, the car is gonna move, right? But it moves thanks to those batteries. So this one is potential energy. What about this windmill?
Kinetic.
This is kinetic because it is in movement. Kinetic energy. This girl, what is she doing?
Kinetic energy. She's running.
She's running. She is in motion. So kinetic energy, it is here. What about this dog?
Potential.
Potential. It is sleeping. The dog is sleeping. This one?
Kinetic.
How is it? It's open or closed?
Potential. Potential because it's not moving.
It is closed. So it has potential energy. Like the lamp here. This lamp is off. So has potential. But when the lamp is on, has kinetic. A log in a fireplace. Un trozo de madera en una chimenea. It's just there, pero no está encendido. So has potential energy. When the log is burned, it is burning, so has kinetic. This water, kinetic energy, because it's not still. The water in the oceans is always in movement. So it's kinetic energy. So far, so good? Did you understand the difference between potential and kinetic energy, guys?
Yes.
Yeah, questions? No? Okay. No homework in science. Thank you for your attention, guys.